In example 2, we are given a slope field with a lot of little slopes. And let's go ahead and take a look at what the question is asking us to do here, maybe some of the answer choices. So we've got a slope field for a certain differential equation above. Which of the following could be a solution to the differential equation with the initial condition? And there should be a y of 0 here is equal to 0. So what we can do is we can maybe get a picture of what this graph looks like by plotting a possible solution curve through 0, 0 here. And that's going to look something maybe, well, that's not going to tip up right there. We're going to try to draw this a little bit better here for you. So there's the shallowing out, and then we'll probably level out here when those slopes are 0. And let's see if we can figure out which one of these, A, B, C, or D, happens to be the equation that we've graphed above. Now, this one might be kind of tough to figure out just by looking at the slope field and the red line, because I don't know about you, but I don't know what these graphs look like. So one thing that you can do is you can work with each one of these equations, and you can try to find the derivative. And we can use the derivative actually to help us to figure out the different slopes. So let's take part A, and what we're going to do is we're going to find the derivative of each side. So dy dx will be equal to 1 over 1 minus x. And then remember to use the chain rule, so the derivative of 1 minus x is negative 1. So this will be negative 1 over 1 minus x. What we're going to do here, you can pick any point you want, but I think the best point to pick is 0, 0, because we definitely know that that's on the actual curve. And it looks like the slope is about 1. So if we're looking at the slope right here of the tangent line, that looks to be about positive 1. So we need to make sure that that actually works with our differential equation. If we take 0, 0 and substitute that in this case, we don't have a y, so we just need x being 0, we're going to wind up with this. So we're going to have negative 1 over 1 minus 0. That's going to give us the slope of the tangent line at the point 0, 0. And that's going to be negative 1 over 1, or negative 1. And if we look back here, the slope of this tangent line right here is clearly not negative 1. It's close, or is positive 1. So the first one here, A, cannot be the correct choice. We'll change up colors on you. Maybe pick something else. Yellow might not be that usable. We'll go with green here. So what we're going to do is we're going to do the same thing here with this one. And so if we take the derivative of y with respect to x, dy dx will be negative 2x times e to the negative x squared. That's the chain rule there for you. And then we've got minus 1. So let's go ahead and try the same thing that we did before. Let's substitute a 0 in. Oopsies, and I made a little mistake there. The derivative of negative 1 is 0. So we'll just erase that. And we'll check what happens when x is 0 here. So we're going to have negative 2 times 0 times e to the negative 0 squared, which happens to be 0 times 1. So we've got 0 times 1 here, which happens to be 0. So the slope is definitely not 0 up there. So we're going to get that off the list. And then we're going to switch up colors here again. So let's see if I can't reach that palette wheel. So we're going to have to just deal with what we got. So we'll do like a light green here, I guess. So let's take a look at this one. Hopefully you guys can see that there. Looks pretty readable. And we're gonna try to find the derivative of this one. Now this is going to be the quotient rule. So if we find dy dx here, we've got, it's supposed to be an x. We've got, let's see, low d high, so that's 1. The derivative of the numerator is 1. Low d high minus high d low. The derivative of the denominator is negative 1. Square the bottom, and away we go. And we're going to see what happens again when we substitute x being 0 in for this one. So we're going to have 1 minus 0 times 1 minus 0 times negative 1 all over 1 minus 0. Oops, forgot the 1. squared. So this one's going to be equal to, oh, let's see, 1 minus 0 is 1, minus 0 is 1, and then 1 minus 0 squared is also 1, which turns out to be 1. So this is a definite possibility here. We're gonna think real hard about this. We're going to check out part D, though, and see what's going on there and see if we can definitively figure out what's happening here. So let's go back to part D. I'll scroll up just a little bit. We'll show that work down here. So I've got dy dx. Same rule here. This is going to be the quotient rule. So we'll go low d high minus high d low. And we'll square the bottom. And away we go is the old rhyme there for that. So let's try to figure out what's going to happen with this one if we substitute 0 in for x. So I think this first part is going to be 1. 1 minus 0 squared is 1, times 2 times 0, which is 0, minus 0 squared, which is also 0, times negative 2 times 0, which is 0. And then in the denominator here, we're going to have 1, let's see here, 1 minus 0 squared, and that has to be squared as well. So we wind up with 1 over 1, which is also 1. So maybe this one right here. So for that one, we're going to try to think real hard. And I made actually a little whoopsie here. So I don't know if you caught it in the video, but how silly of me. 1 times 0 is 0, minus 0 is actually 0. So we're going to go back here. We're going to change a few things here. That's what you do when you make a mistake. You fix it. And so actually 0 divided by 1 is 0, and that's going to make our decision quite a bit easier. Part D cannot be the solution, and instead here what we thought was true actually is the solution, and that's C.